Again, a warm welcome to the audience. And this is the part 2 of our video, along with the founder of AppsCode. And today we will be doing a live lab, like I discussed in the context of the last video. And this live lab is going to showcase SockShop as a reference use case for evaluating or actually working with what AppsCode has to offer in terms of 3 offerings right now that we will be dealing with. One is KubeDB, which will give us database as a service construct on top of Kubernetes. Second is KubeStash, which will give us database backup and recovery as a service. Third is KubeVault, which is all around secrets management with Vault as a service. Now, I think if you've seen my previous blogs, you would have seen a lightweight deployment of SockShop from a persistent standpoint. We really did a basic deployment of SockShop and understood how persistence works actually. Now we're going to augment this scenario through quite a robust structure. But before I do that, I would again like to welcome the AppsCode team. Hi, Kamal.
Hi. Thanks for the opportunity.
Kamal, as you recall from the previous video, is the founder of AppsCode, quite an engineer at heart, and hands-on for sure. And also in the call, we have Dipta and Dipto. They are also from AppsCode doing sales engineering and solutions engineering role. And I have Abdullah from their solutions software engineering team. I'm also joined by my colleague, Dawn. Hi, Dawn. Okay, so let's just reflect on this visual towards the scenario that we are dealing with. We have 2 EKS Anywhere clusters that we will build in this live lab. So you will see the clusters coming up. Once these clusters are up, we will be deploying, the basic requirements around MetalLB, Ingress, cluster autoscaler, some of the nuances around, how to actually integrate both the clusters with our Dell's software-defined storage from a PowerFlex platform. And this will be done through a container storage interface. So this will be a CSI integration with EKS Anywhere and PowerFlex. Once that is done, we will then start to deploy the first prerequisite, or the entire sequence will be from a KubeVault perspective, which will give us the ability to perform secrets management for the database secrets that we will be using within the databases that will be rendered in SockShop. We are also going to work with HashiCorp's new latest entry in this space called as Vault Secrets Operator, which is a very dynamic way of injecting secrets and then rotating them as the changes happen on the Vault server. So this is a very good exhibit here that we will be dealing with. We'll then move over to deploying KubeDB operator, which will then instill the ability to create database as a service. And then finally, we will deploy the SockShop application with MySQL, MongoDB, Redis, and RabbitMQ. So 4 different database or data services, along with the microservices that are running inside of SockShop. We will also be deploying the Locust load testing suite on top of Kubernetes so that we have the ability to generate load and see some of the auto-scaling aspects of EKS Anywhere when load is exerted. Also in the mix, we will bring together Prometheus Grafana to actually see how we can monitor our databases from the Kube metrics capability that KubeDB provides us. Finally, we will observe what is called as KubeStash and its integration with Dell's object storage as a backend to actually, through REST, take database backups and snapshots and store them on ECS. And then whenever required, we will also observe the ability or the capability to recover the database at a point in time. So that's a quick summary of where we are heading to with this whole live lab. Tamal, any thoughts from you?
Yeah, I mean, this is quite expansive use of all these different components that we have been developing, and I think it will give you like a real world scenario or example where these multiple databases are involved. You're taking backups, so it's kind of like a production or the environment example to see all these sort of components or tools, products in use. So yeah, so that'll be exciting to see.
Thank you.
Yeah.
Okay, so let's move on. And to start with, like I've mentioned, all this detailed execution of the lab is documented. For now, it's stored in a gist. As we wrap up this video, finish the recording, we will move this content of execution into the blog, and you could, experiment in your own turf, given that the simplicity of the deployment is already kind of out there as a written content. So let's start ahead by creating these two EKS Anywhere clusters. These clusters would take anywhere from 12 to 15 minutes of time to come up. I will not delve into the specifics of it in terms of describing the cluster and all that, given the previous blogs have detailed information of how to create EKS Anywhere clusters. So I will head over to my terminal here. Let me increase the font size a little so that it's visible. Screen is a good one. Yeah. Is that good?
Yep.
Okay. Or I think 14 is better. I think it'll just, sorry about that. I'm a little finicky on, making things appealing for the audience. I think 16 is a little large for me too. Okay. Okay, yeah, this is good. So the first step is, okay, we have a scripted way of actually creating the EKS Anywhere cluster, and I'm gonna move ahead with that. Let me name this cluster as M1. Okay. The IP address that I'm going to give for the API server is going to be, let's say, 55, 10.204.111.55. And I have some templates. So this cluster is going to host our Vault server as like a centralized secrets management as a service. So I don't need a huge cluster, it's a single workload. So I'm gonna put a consolidated cluster here, which will run a minimal footprint. I'm gonna go to, let's say, 1.25. Okay. And while this is happening, we will also build our another cluster, which is M2. So I will open up another terminal here. As you can see, the cluster creation process has started here. Let me go and hop over to another terminal. Okay, and I will repeat a quick change of settings here so that we get the font that my old eyes can dig into. Okay, so 14 is it? Yeah. And we will start the creation of another cluster. Let's name it M2. And this time the cluster's API address will be 58. And instead of having a consolidated 2-worker spread, 2-worker nodes, we're going to use a bigger cluster, which will have roughly around 8 worker nodes, 3 control plane nodes, and 3 etcd nodes, which will be outside the kubelet configuration. So all in all, you have about 8 plus 3 plus 3. Math is right. That's about 14. Yeah, so 14 nodes, quite a decent size cluster. So let's take this particular thing and put it into action. Let's go to 1.25. I know 1.27 is there. I'm still, oh, sorry about that. Did I say, okay, yeah. So it's a good validation of the script that it's working. So yeah, I have cleared up the static IP, which was advertised wrongly for some other host machine. So I think we're good with this IP address. Let's continue. We will set up the cluster again. M2 it is. 10.204.111.58. And we will grab the bigger cluster template, 1.25. And let's hit the execution. So as of now, there are 2 clusters which are getting created. What you see here is M2, and on the previous terminal, we have M1 going on, right? So like I said, this will take about 12 to 15 minutes for the cluster nodes to fully come up and the cluster to be ready. Once the cluster is ready, we will then start the basics in terms of CSI, load balancer, ingress, and those things. So I'll pause the recording here and we will join back or resume the recording when this cluster is fully created. Okay, cool.